this is the problem of function and graph. Here we have f of x as greatest integer of x, which is defined as the greatest integer less than or equal to x, which means if x is 1, f of x will be 1. When x is 1.2, f of x will remain 1, as it is less than or equal to x. If x is minus 1, f of x will be minus 1. When when x is minus 1.2, f of x will be minus 2, because the integer which is lesser than minus 1 by 1.2 is minus 2. And further it is given that gx is fx square and hx is mod of gx. Here, even if mod would not have been there, hx would have remained non-negative quantity, as gx is square of some quantity. And finally we have to check which of the following is true. Here we are not going to find too many values of functions by taking various values of x. We just see the broader picture of graph, what would be the possibility and what would not, and on that basis we'll answer this question. Now look at the first option. Here we can see that value of h of x could be negative as well, but practically which is not possible, as h of x is modulus of g of x, so it has to be non-negative quantity. It can be 0 or some positive quantity, but it can't be negative, so option A is eliminated. Now coming to option B, which is a graph between x and gx. So we just need to check whether whatever given in the graph holds true or not. As per the graph, when x lies between 1 and 2 excluding 2, value of gx is 1. So if x lies between 1 and 2 but it is not equal to 2, but it can be equal to 1, then value of f of x is always 1. And when f of x is 1, g of x will also remain 1, because square of 1 is 1. And similarly, when x lies between 2 and 3 but not 3, value of f of x will always remain 2, and in that case value of gx, which is fx whole square, will be 4. So which is true, and next value also of gx is valid. Now coming to on left half of the coordinate, here it says when x lies between 0 to minus 1 but not 0, value of gx is plus 1, which is true, as we have already discussed. When x lies between 0 and minus 1 excluding 0, f of x will always remain minus 1, and the value of gx in that case will be plus 1. And similarly, when x lies between minus 1 and minus 2 excluding minus 1, value of f of x will be minus 2. In that case value of gx will be plus 4. So graph B holds true and it has to be our answer, but we can check other graphs as well just to see whether they can be answered or not. In option C, if we look at the graph, then we can say that in first quadrant it matches exactly what it is in option B, but same does not hold true for second quadrant. Here it states when x is lies between minus 1 and minus 2 excluding 2, value of gx will be 1, which is not true because we have already discussed that when x lies in the range of minus 1 to minus 2 but not 2, value of gx is 4. So this option is ruled out. Now coming to graph or option D, here it is graph between f of x and g of x. So first thing that we need to understand here is whether this graph will be of ladder form as it is shown or it will be in form of points. We know that value of f of x can be only integer, it cannot take any other value apart from integer. Consequently value of f of instead g of x will also be points or integers only. So this graph would not hold because it shows continuous regions. Therefore option B is the correct answer.